So I want to do a nice little example video here of adding vectors together. And remember, all you really need to know how to do is add vectors, because even if you're subtracting them, you're just adding the negative of it. And it's going to be kind of an example, a little bit of a complicated one, because I'm going to add together like three different uh, three different vectors. So it'll look like, oh, it's way complicated, but really all it'll be okay, because it's going to nicely demonstrate a few different properties for me. So first thing I want to do is just go ahead and define a few vectors. So let's make a vector A, and let's say that this vector looks like that. Oh, I don't have the right tool selected. So let's say this is vector A, and we'll make that vector A, and then we can have we'll come over here a little ways and we'll do a vector B maybe that does something like this. Okay, I'm trying to keep these nice and on these squares as I can. And then we'll do a vector C that maybe is just a straight down vector that goes like that or something. And that'll be vector C. And so the first thing I want to do is just go ahead and look at the components of this, because anytime we're wanting to add these vectors that aren't at right angles to each other, we're going to try and make it into a bunch of vectors that are at right angles to each other. So first and foremost, I'm just going to go ahead and do that. Let's take a look here. Let's see. This I can just count over 1, 2, 3. So this has a length of 3 on this side, and then this has 1, 2, 3, 4 right here. So I'll just write a 4 there just so I remember the lengths of these. This is really just a sub x, but it has a length of 4 or a length of 3. And then over here for b, I can do that same sort of thing. We're going down 2, so that's a negative 2. And over here we're going over 1, 2, 3, 4, so that's a 4. And then here for C, it only goes down. It doesn't go horizontally at all. And this just has a length of 1, 2, 3, just 4. Okay, so now I have these. They're broken into components, and I can start asking myself, what is A plus B plus C? All right, so just what's the sum of these vectors? What is this resultant? What is it going to be? And it's going to pretty much all be the same thing. And I'm going to actually change this question mark into an R for resultant. So that's what we're looking for, and we're going to do it a few different ways. We're going to try adding them just a normal way, and then we're going to try adding them just by numbers, and we're going to try adding them graphically here, and we're going to try switching the numbers up. I hope I can fit all of those ways in here. But so let's go ahead and let's just try first. Let's add these graphically. So graphically speaking, we can just do this. We've got vector A where we go over 3 and up 4. So that's over 3 up 4. So vector A will look like this. So there's A. And then we can do plus B, which is over 4. 1, 2, 3, 4, and down 2. So B would then put it at the end of the first vector, and you then remember that walkable path. You'd walk along A, and then you'd walk along B, and then we'd walk along C, which is, oops, I actually put C just down as 4. That's a negative 4 there, sorry. And then we'd walk along C, which would be then just straight down 1, 2, 3, 4. Okay? And this would get us from our starting point to our ending point. And the overall resultant then would be this vector here, right to there. And if I wanted to know what the resultant was, I could just count this up. And I could just see, I could grab out a ruler and measure this length of R, right? I could measure its length, or I could sit here and count and say, all right, it's 1, 2, 3, 4, 5, 6, 7 in the x direction, and down 1, negative 2 in the y direction. So I could say that R is equal to its Rx component, which is, what did I say? It was 7, 1, 2, 3, 4, 5, 6. So 7 in the x direction, and then down 2 in the y direction. And if I wanted to know its length, I could then just do, the magnitude of R, of vector R, is the square root, just Pythagorean theorem, of 7 squared plus negative 2 squared, and take the square root of that, and I'd have what r is. So this would be what? 7 squared is 49. This would be 4, so it would be the square root of 53, right? So whatever that would be, square root of 53. It's going to be a little over 7, but so somewhere around 7-ish, 7-ish for the length of r. And that's what we came up with just doing this graphically, just like that. So first question is, what would happen if we were to switch the order of this? Well, I'm going to just do this in a different color, or actually maybe just do it next to it, because I don't think I left myself enough room there. But let's do it next to it, and let's do this, let's pick a different color here. Let's just, well, that's probably not going to be very visible, so let's go with a color like this. And so let's start kind of similarly. We'll start right here, and we're going to go down. We're going to do C plus B plus A. We're just going to reverse the order. So if we do C first, C is going to come down 4. 1, 2, 3, 4. So there's C. And then we'll do B. B goes down 2 over 4, so it should end up there. So there's B. Down 2 over 4. There's B. Okay? And then we'll add on A, which goes over 3, 1, 2, 3, and up 4, 1, 2, 3, 4. And then we would do this. Here's A. And then our resultant, I'll go back to that nice blue for it. The resultant will be from where you started over to where you finished. And it would be that. And if you look, this resultant, and you compare it to this previous resultant, you can see they're the same. This one went down 2 over 7. This one goes down 1, 2 over 1, 2, 3, 4, 5, 6, 7. So we got the same result, even though we added these in different orders. And we could do a third one. You could do B first. In fact, maybe I'll do that kind of lightly on top of it in yellow. You could do B first, which would be down 2 over 4. So B would take us 1, 2, 3, 4. So you'd get B here, and then you could do either A. You could do A, so you could do like BAC. A is over 3 up 4. 1, 2, 3, 4. So A would take us to there. And then if we added on B, or C, sorry, so this is B, then A, then C, and this one I'm showing you right on top of, because I'm not going to do any other method, but C would just be down, straight down 4, and look at that. We end up right at the same spot we were, even though our shape here is nothing like what it was. We get the same ultimate thing, that these are all the same. So what did we do? We did A plus B plus C. We did C plus B plus A. And then we also did, what did I do? I did B plus A plus C. And I'm sorry, that yellow is not showing up very well, but they all still equaled that same R. So we got the same answer each time, and it works out really nicely. Now if you're doing this graphically, this is a great way to do it. You can just draw these out and you know your final thing. If you're out walking somewhere, if you have directions on how to get somewhere, like with a map and they're telling you walk this many paces north and then this many paces west and then this many paces south, you can do the paces really in any order and you're going to get to the same place. The other thing we can do with this is we can try and turn this into doing just a regular old right triangle. And the way we did this was we added up just the horizontal components and just the vertical components. And I'm going to do that before, even though I think I showed this already, but let's go ahead and just do that real quick. So I could just do, we could just do, I'm going to do it up here. We could do the a sub x, so we could do this 3 first, so we could, here will be our starting point, and we can do it 1, 2, 3, and then we could do this one here, this 4, so we could do 1, 2, 3, 4, and we get here, and then for C, there's nothing to do, so that's all we have. This was a sub x, and this was a sub x, and this was b sub x, and then c sub x is 0, so there's no c sub x. And then we can go and add in the vertical parts, in which case I'd have, and I'll swap to a little bit of a different green here. We'd have a sub y, which is 1, 2, 3, 4 up, and then we have b sub y, so this is a sub y, and then we have b sub y, which would take us back down to, it's a minus 2, right? So this would be b sub y, and then we would have c, which c sub y would just be down another 1, 2, 3, 4, and it would take us right to there. So this from here to here is c sub y, and we would get a resultant, and this resultant is going to be this guy right here, which is, again, just like before, it's down 2, 1, 2, and over 7. 1, 2, 3, 4, 5, 6, and 7. So this is, again, the same resultant r, okay? And ultimately, by doing that, what did we end up creating? Well, we created, and you can see it right here in the picture, we created a right triangle, right? And r would be the hypotenuse. This would be that right angle right there. And the length of this side would just be a plus b. It'd be 3 plus 4. And the length of this side would be the sum of all of these. It would be 4 plus negative 2 plus negative 4. So 4 plus negative 2 plus negative 4, and we would get this nice right triangle. So that would be the length of the vertical side, and this is the length of the horizontal side, and ultimately this equals 7, which is what we got for the length of the vertical side, or I'm sorry, the horizontal side, and this would equal negative 2, which is what we got for the vertical side, this minus 2 here. And that then doesn't matter. And we got this nice right triangle out of it. But even with that, we don't have to stay in the same order to get that same result. So let's do this one more time. And let's add these up another time, but let's this time alternate between, you know, this and that, and we're just going to I'm just going to kind of pick an order. So let's start with, you know, this will be our starting point. Let's put it somewhere to make sure I don't run into another drawing. Let's put it here, and let's do, let's start with this one, minus 2. So we'll go minus 2. That's our b sub y. And then let's do this 3. So we'll do a sub x, 1, 2, 3. So a sub x. And then let's just do, I don't care, let's do the minus 4 of the c. So let's go minus 1, 2, 3, 4. So there's our c vector, right? These are vectors. And then let's do, so we've done, so we did this one, we did this one, we did this one. Let's just pick one of these. Let's go with, let's go back to b, I guess. And let's do the plus 4 on b. 1, 2, 3, 4. So that's b sub x. And then we need to add on the last one, this one, for a sub y, which is up, which is up 4 in y. 1, 2, 3, 4, and that puts us right to there. And so this is a completely different path than we would have followed here or any of these times, all these mixed up things, but it puts us right to here, and this is a sub y. And then if we draw in our resultant, what do you think we're going to get? We get this guy from our starting point to our ending point. And if we look at it, it's down 2 and over 1, 2, 3, 4, 5, 6, 7. So it's again that same exact r with negative 2 in the y and 7, positive 7 in the x. We're getting this same r. Every time we do it, it doesn't matter which method we use. If we just try and graphically add up these vectors just like that, or we flip them around in a different order but we add them up straight, or if we break them into these components and add up the components first. We can add up all the x components and then all the y components, or we can just kind of randomly do them in any order we want. Now, By doing this, we didn't really end up with something where you could clearly see a right triangle in it like we could up here, but it gets the job done. So you can ultimately end up doing this, and you get that same result where you can do the same Pythagorean theorem on it, and it works. And then the same sort of thing, like I did right here. I won't redo it, but well, maybe I will. You could have just done what I did right here, where I know I drew it out graphically, but I also did it mathematically here, where all I did was just add up the x components and add up the y components, and it would give me the same thing that I ended up doing right down here, right here, where it was just 7, because I got a 7 here, and a -2, I got a -2 here, and I don't even have to actually draw it out. I can just do it purely mathematically. I did the math along with this picture, but I didn't have to. I could have just broken it into components and then done it purely mathematically. So I hope this example kind of helps you see that how these vectors work a little bit. In every picture, I always had a starting point, and then I always basically started with my first vector, put it there. When I got to where it ended, I put my next vector, added it on, and then I added my third vector. And I did that in every one. I did the C vector, then I added on the B vector, and I added on the A vector. And remember, I think I keep saying that it's like a walkable path. If you were going to be a little guy, walking along here, you have to be able to walk along this path. You couldn't do something like here's A, which is what? It's over. So this would not be right. I wouldn't go over 3 up 1, 2, 3, 4. So I couldn't do vector A like this and then say, all right, well, what's vector B? Well, B is here. I couldn't do this. If I tried to do this to add vector A and B, well, if I walked along A, it'd be pointed here. Well, B's pointed right here too. They're pointed to the same spot, so that wouldn't work. I'd have to walk along here, and then I couldn't walk along B without going in the opposite direction of its vector, and then this would just be wrong. You wouldn't want to do that. If you were going to add B, you have to then continue from where you finish. So you walk along A, get to your ending point, and then you will continue on your next vector, which would be that. That would be then B, and that would be the correct way to add B onto A. And then if you had other vectors, you just keep going on from there to add C on, and if there was a D, you could add it on, and everything like that. So out of all these ways of thinking of it, as long as you're adding these vectors tail to tip like this in this walkable path, you can walk along this without ever leaving. You just walk along B, then A sub Y, then C, then B sub X, and then you walk along that. You're always following the arrows and walking in the proper direction from your starting point to your ending point. And then it doesn't really matter which of these methods you use to come up with the answer. You do need to know how to do it mathematically because you're not going to always have a graphical paper there with you. But as far as if you're asked to draw them out, it really doesn't matter which way you do these. They're all going to give you the same answer, and you can kind of just pick which one works best for you. If it's all the same for however the question is being asked, you can pick which one works best for you and go with that one. Of course, if the question asks you to do it in a certain way, like either graphically or mathematically or something, then you have to pick either, you have to do it the way it's asked. So you do need to know how to do it graphically and mathematically. But as far as graphically goes, it doesn't really matter if you do it like this, where you break into components, or you do it like any of these others where you just left it straight in the vectors and you drew the arrows out and followed it from end to end. And then also the order doesn't matter. So you just pick whatever order makes sense to you. You pick whichever method makes sense to you that's allowed within the way the problem is asked, and you do it. All right? So hope that cleared some stuff up, maybe made it a little bit more understandable for you. And that's about all there is for that.